Hi guys, what's up? How are things? Take this away. Where's the comment section? What's up, Miral? What's up, Talal? How's the audio? Looks okay. 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 Yeah. Okay. This is strange. Okay. Okay, let's open chat. Bring this here. Bring this here. No, this here. And I guess this is fine here. And we can start. I don't know why there are two screens. Shall we? Element X has two isotopes. Looks like they're talking about carbon 12 and carbon 14. And this looks like it has 6 neutrons. And this looks like this has 8 neutrons. Which statement about these isotopes is correct? They have different chemical properties because they have different numbers of neutrons. No chemical properties will not change because isotopes, right? They have the same chemical properties because they have the same number of outer shell electrons. Yes, I think we have our answer, but I'll just read through all the options. They have the same nucleon number because of they do not have the same nucleon number. It's 12. This is the proton number or the atomic number. So C is wrong. They have different positions in the periodic table because they have different numbers of neutrons. No, that's not how. Isotopes don't have different places on the periodic table. They have averaged values on the periodic table. Case in point, chlorine, right? So our answer is B, I think. B, right? B is our answer. Okay. Question number 8. We're gonna try doing all the. Yes, Miral, I am on Zoom. I just shared a link on the chat so you can join Zoom from there. Oh, I have to add Miral. Sorry. Oops. Oops. Hey, what's up? Hey. Okay. Let's continue. Which statement describes the structure of copper? It has a lattice of negative ions and a sea of electrons. It has to be. Why is it like this? Sea of electrons, and the lattice has to be positive. So C is our answer. The answer is C. Question 9. 4 fertilizers are each supplied by supplied in 100 kilogram bags. Which fertilizer supplies the greatest mass of nitrogen per kilogram? Okay, how do we do this? I was looking at this question earlier. I didn't solve it. I'm wondering what's the fastest way to solve it. I have no idea, so I'll just solve it. If I take a closer look, maybe I can find a shorter way, a quicker way. One way I'm thinking is, no, that won't make sense. I was thinking all the MR of nitrogen, add them up, then divided by the total MR. Would that give us a good number? That should work, right? But what if you have more moles of something? I have a slight lisp today, or every day. Okay, let's just do it. Nitrogen is, I believe, 14, right? Nitrogen is, the MR is 14. So we just essentially have to find out the moles of nitrogen in each of these. The moles for A is going to be mass over MR, right? So the mass, yeah, mass is 100 kilograms, which means, 1000 divided by the MR, which is 14 plus 14, and 16, this is 14 times 2 plus 3 times 16 plus 4 for the hydrogens. So that's 28 plus whatever 3 times 16 is plus 4. Those are the moles. Those are the moles. And my calculations will tell me real quick. 16 times 3. 48 plus 28 plus 4. 80. 100,000 divided by 80. 1250 moles. So the total moles in 100 kilograms are 1250, and there are 2 nitrogens over here each, right? So each mole of ammonium nitrate will give me 2 moles. So 1250 moles will actually give me twice the amount of ammonia, which is going to be 2500, if that makes sense. Take it. For B, let's change the color. For B, same thing, moles is equal to 100,000 divided by that ammonium is 17, multiply that by 3, plus phosphorus, I don't know, it's MR, but 64. And what's phosphorus? Periodic table. Nitrogen has more number of moles. Nitrogen has more number of moles? You think it's B? Oh, there are more moles in that? Yeah, that's smart. But there is one flaw in that argument. Can you figure out what that is? Phosphorus is 31. Okay, let's calculate it for the second one. 17 times 3 plus 64 plus 31. That's 146. 1 divided by 146. And how many do we have? We have 3 nitrogens. I'm getting 685. Multiply that by 3. I'm getting about 2504. So B is failing. B has less nitrogen produced for 100 kilograms than A. So far our winner is A. I'll continue with C. I have a strong feeling C is not it either. And I think you guys can understand why, or why is B not winning. Can you guys see why? Okay, let's taking a closer look at C. Moles are equal to, again, what do we have? 17, the mass of MR of ammonia, times 3. Oh, sorry, times 2 this time. I was looking at the wrong equation. Plus sulfur, which is 32, plus 64 of the 4 oxygens. And this time around, 2 times 17 plus 32 plus 64. 130 divided by 130, 769. And how many nitrogens do we have? We have 2, so multiply this by 2. 15. C is 15. 38. Shocker. Ammonia's MR is 18. Ammonium, oh, yeah. Yeah, this is meant to be 18, but it's going to be very close, so I think I'm in the safe region still. I'm off by 1, right? So I think I won't redo my calculation, but thank you for the correction. Okay. D. Yeah. Okay, urea, which is going to be moles, is 100. Maybe my answer might be off because of the incorrect. 12 plus 16 plus 2 times 14, 15, 16. 16 for the NH2, right? That's 32 plus 16 plus 12. 60. 100,000 divided by 60. And I'm getting 1600, and I have 2 nitrogens. Multiply that by 2, and I'm getting, whoa, look at that. I'm getting 3333 moles for each of these. This is for D, and this is for C, that's B, and the yellow one is A. I'm not too sure if there was a faster way. I kind of knew it was D. You know why? Because I know the sulfate ion is very heavy. The phosphate ion is heavier than definitely carbon and oxygen, right? So what's really going on here, you have ammonium, right, in at least 3 of them, and NH2 in 1 of them. But whatever they're bonded with seems to be very heavy compared to urea, D. So this is carbon and oxygen, where the mass is 12 plus 16 for anything that's not connected to something that's nitrogen-ish, right? So that's 12 plus 16, what is that? 28. And if I check out the MR for this, that's 32, that's 96 or 98, I think 96. This is again in the 90s, some 90 something. And this one is still pretty high, close to the 40s, 50s maybe. So really high MRs from everything else. Do you guys understand what's happening? Do you guys see why it's not B? Yep, straight obvious. If you do the calculation once, you understand it really well. Maybe right now it's kind of hard for me to explain why. Not really hard, it's just long, and I feel a bit lazy, I guess. Procrastinating. But I guess once we calculate, you just realize, oh, it's D. Okay, that makes sense now. Okay. But I don't think if anyone asks a question, I'll come back to explain why. But for now, we shall move on. Question 10. Calcium carbonate reacts. Sure. 1 gram of calcium carbonate is added to 50 centimeter cube of 0.5 mole per decimeter cube of hydrochloric acid. What is the volume of carbon dioxide made? Okay, I think this is a limiting agent question. We have to find the moles over here and the moles over here and figure out what's the limiting factor, if there is one. So moles of calcium carbonate are 1 gram over the MR for calcium carbonate is 100. So that's just 0.01. How neat. At least they're making our lives easier by giving us easy calculations. Okay, 50 centimeter, the moles are going to be concentration times volume. Concentration is 0.05 and the volume is 0.05 as well. This is, oh, that's very little, right? 0.05 times 0.05. 0.0025. Sorry, I put it under the wrong thing, right? So what's the limiting factor? I think this is too much. This is your limiting factor. What is half of this? They're reacting in the ratio 2:1. So divide this by 2. I think you'll get 0.00125. We have way more than 0.00125, right? So they'll react in this ratio. This value is going to be 0.00125. That's what reacts to produce 0.00125 moles of carbon dioxide, the volume of which is going to be 0.00125 times 24000. Huh? 0.00125. 30. Look at that. The answer is A. Right? Easy? Straightforward. I don't think this is tricky at all. Yes? Okay, moving on. 15. Which is a chemical change? I think people just were confused with this question. And what do you guys think? What's the chemical change over here? We could also just take the percentage of nitrogen. Abdul Ghani, that's what I think Talal did. And you might just get the wrong answer. What's happening with this question is it's two things are contributing to the amount of nitrogen in this 100 kilograms. One is how much, for each molecule, how much nitrogen is present in that each molecule, right? So the more the nitrogen, the more it will be given out and absorbed by the plant when it's used as fertilizer. The other thing is, how heavy is that? Oops, what happened here? Oh. The other thing is, how heavy is that molecule? So if it's a very light molecule with one nitrogen versus a very heavy molecule with one nitrogen, do you realize this would give you less nitrogen in the same mass? Because there are less moles of nitrogen, right? For a tiny molecule, there are more moles of that molecule in 100 grams. That's literally what we're talking about. And so between these two molecules, the tinier one will have more nitrogen. So not only do you have to find out which molecule has more nitrogens per ratio, but you also have to figure out which molecule is more of in the 100 kilograms. So you just literally have to calculate the moles because the K are just very difficult, right? Because thinking about this any other way would probably take you longer than. The really good help is, I think the examiners were expecting you to realize, hey, this is very light. So not only does it have more nitrogen, this entire thing is very tiny, so you'll have a lot more moles, right? Look at the MR over here. What is this? What did this total to? 32, 42, 48. Yeah, somewhere around 48, where every other MR is higher than 100. This is close to 60, I think. Every other MR is 100 or higher. That's what's making the most change, not the number of nitrogens, because all of them seem to have at least 2 nitrogens, right? But moving on. What is a chemical change? And dissolving sugar, Miral thought was a chemical change. One way to understand a chemical change is, unless it's a reversible reaction, if a chemical reaction takes place, it's kind of difficult to go back to the original thing, right? So if you boil water, you can always, go back. If you dissolve sugar, you can always undissolve it, right? If you melt ice, you can always freeze it. But if you cook an egg, you can never uncook it because the proteins are actually disfiguring. It's a chemical reaction taking place, right? And that's an easy way I just thought of while looking at this. It's kind of difficult to go back in a chemical reaction. Depends, right? Okay. The rate of reaction between magnesium and dilute hydrochloric acid is increased by increasing the concentration of acid. How does this affect the reacting of particles? Collision of particles should increase. Proportion of particles with sufficient energy. There should be more, right? Does that make sense? Okay, let's figure it out. Increases, stays the same. Okay. So I'm confident about this, but I'm kind of confused about this. Stays the same versus increases. You know why? Because it's not saying number of particles. That's why I'm confused. I think when you if you increase the concentration of hydrochloric acid, you have more particles, and there will be more particles higher than the sufficient energy, or more particles having energy, then activation energy, hence your rate of reaction is higher. That's essentially what more particles do. But the proportion will remain the same, right? Because the temperature isn't changing. So in our, remember our skewed graph, the skewed graph isn't changing, but the graph is bigger, I guess, right? It's just bigger. So when you divide it, the proportion is the same. To successful to non-successful is the same for a bigger graph, you know, but numbers is increasing. You love the fact that Sir is in dark mode, right? Do you guys understand this? I think the answer is B. I'm confident the answer is B. Yeah? Does this make sense? And it all relies on this word proportion. It's an English test rather than a chemistry test. Yep, makes sense to everyone? Yes, moving on. Same properties of substance X are listed. It conducts electricity when molten. It has high melting point. It burns in oxygen. And oxide dissolves in water to give a solution with pH 11. And they're just talking about a metal, and don't you forget it. Because if you want to know why, I think this is the confusing bit. This could mean either a metal or ionic, right? High melting point, this probably means more ionic than metal, but it could be both. So nothing is helping us so far, aside from the fact that C and D, like you should know A and B are already out, right? It burns in oxygen, and the solution, the oxide has a pH of 11 when dissolved in water. That's a metal oxide they're talking about. Ionic compounds could be an oxide, right? Like they don't have oxides. So C is the answer. Our answer is C. Easy? Last question from this paper. Okay. You know, I'm surprised. We look at the most difficult questions highlighted by CIE, and we barely see organic questions show up. But let's try doing this question. The diagram shows the structure of monomer, polymer made from it. What are the monomers and the polymer? This is ethene because it's a alkene, and this is polyethene, right? So this was difficult. I guess people just don't understand organic chemistry. It's not ethane. Polyethene. It's called polyethene because it's made from many ethenes, right? Ethanes do not, or you know, I should say alkanes do not react to form monomers. And what's the answer? D. D. Right? And we're done with November 2-1. November paper 2-1. This is IGCSE papers. ठीक है. But I think all of these questions can be applied to. They're exactly the same as you'll expect, or you probably saw at least half of these in O levels as well. Right? Yep. We just did 1, 2, 3, 4, 5, 6, 7, 8. 8 of the 40 hardest questions. I think we've built speed. Okay, is this the first question? Question 10? Okay. Calcium carbonate is heated. Calcium oxide, is this the same? Oh no, different question. You'll see similar questions show up because in the variants they try to keep consistency, right? Calcium carbonate is heated, calcium oxide and carbon dioxide gases are formed, the equation for the reaction is shown. Yeah, 225 kilograms of calcium carbonate is heated until no further change in mass is seen. The yield of calcium oxide is 85. What is the percentage yield? The yield, okay, this is interesting. I think I understand why people are confused, because I got confused reading the question. What exactly are they asking? Because the yield is already here, right? So we don't know how much of calcium oxide should have formed, but we know how much it did form, and they want us to calculate the percentage yield, right? So how much would it form? You have 225 kilograms. So how many moles are those? Moles of calcium carbonate are 225. You know what I do? When I see a kilogram, especially in MCQs, I'll just take 225. I'll be aware they're talking about, what do you call it, kilograms, but I won't convert it into kilograms. And here's why. You get 225, I divide this by 100, and I should just get 22 moles. Right now, these are the incorrect moles, but if I wanted the right moles, I know I just have to multiply this by 1,000 to convert this into kilograms and get the right moles. So if I want to, I'll convert this into, I'll multiply it by 1,000 at the end. It just makes my life easier, or like simpler, if not easier. But if it's simpler, I can process it easily, right? Okay. Then we have ratios. So the ratio is 1:1 from calcium carbonate to calcium oxide. So we can just move on to calculating the mass of calcium oxide, which is going to be 2250 moles times what? The MR for calcium oxide, which is 40 plus 16, 56. Captain, I can't hear you. Captain. Who lives in the bottom? Who lives in a pineapple under the sea? Okay, this is 126000 grams, or 126 kilograms. Is that right? And we got 85, so the percentage is 85 divided by 125, multiply that by 100. 85, 126. $67. Who lives in a pineapple under the sea? Yes. Right? Easy? Easy peasy? Yes. I forgot my water today again. Nice. Okay. Temperature of the water in two beakers X and Y is measured to be 21.5 degrees. Okay. 5 grams of sodium chloride is dissolved in the water in the beaker X. The temperature changes to 18 degrees. This is very interesting. No one knows this, but if you add a lot of sodium chloride to water, it actually changes the temperature. You know why? So sodium chloride, when it tries to dissolve, so you have sodium ions with a positive charge and chlorine ions with a negative charge. And what happens is you have bonds over here. These bonds kind of break, and these ionic compounds will then bond with water. Yeah, you're not supposed to know this, I guess, but they kind of make semi-bonds with, water molecules, like multiple actually, or they're attracted to them. And this bond forming and this bond breaking, the change in it will give you if one is an exothermic reaction or an endothermic reaction, which is very interesting. You can actually put, a lot of salt in water and mix it, and maybe you won't feel it, but if you had a thermometer in it, the temperature would change. When I found that out, I was like, whoa. Okay, 5 grams of calcium oxide is dissolved in the water in beaker Y. The temperature rose and the temperature fell in the first one. So X is endothermic, whereas Y is exothermic. Let's just read the complete question. Which type of processes are occurring in the beaker X and Y? And we're looking at B as the correct answer. Am I right or am I right? You got over 20 years of MCQs of electrolysis today for what? Is that a Lord of the Rings reference? Mithril? Is that a Lord of the Rings reference? Okay, question number 14. Which gases are used to generate... We've seen this question, haven't we? Actually in an O-level paper, if I'm not too wrong. Or no, IGCSE paper. Yeah, we've seen this. A lot of people were confused if A was the answer. But I think it was not electricity, it was identify a fuel in the given set of things below. Test for sulfur dioxide, you can oxidize it with an oxidizing agent. KMnO4, you know, because SO2 is readily oxidized. So you can oxidize it and KMnO4 will, yeah. Sample of dilute nitric acid is added to lumps of limestone in a conical flask. Wow, look at this question. What? Oh, it's just a explanation question? I thought it was a moles question. A second sample of nitric acid of a different concentration is separately tested. All other conditions are kept the same. The loss in mass of 1 minute at each concentration of nitric acid is shown. Concentration and loss in mass in 1 minute. Okay. So you have different concentrations and measured in 1 minute. So when you have half the concentration, the loss in mass in 1 minute is around 0.15 grams. But if you have double the concentration, you don't have double the loss of mass, but you have close to double, which is interesting. Which row describes and explains the result obtained using from 1 mole of mole per decimeter cube of nitric acid compared to 0.5 mole per decimeter cube nitric acid. Description. Decreases in the reaction rate. Okay, the description is increase in the reaction rate, right? So these are correct. And this is because increase in particle collision rate, right? And not in collision energy, because that is temperature changes that, right? So there's higher rate of reaction. Yeah. Yeah. C. Okay, easy. Does this make sense? Let's try this. Ethanol is produced by fermentation. Reaction of ethene with steam. Which row correctly? Sorry. Go away. Okay. Ethanol is produced, sorry, again, I'm distracted. With ethene with steam, which row is correct? By fermentation? What do you guys think? Use of temperature of 100 degrees Celsius. Needs yeast as a catalyst. I think that's true. Very slow reaction. High yield of ethanol. I think the yield of ethanol will be lower. Fermentation, I know it's going to be a slow reaction because don't they let alcohol ferment for years, right? Closed in those bottles. So also, I mean, it's an organic reaction, it has to be slow. Ethene, I think they're right, 350 degrees. But this doesn't make sense because ethanol boils at around 74 degrees and water boils. So I don't think you heat it at all. So this is incorrect, but this seems correct. Yeah, 350 degrees. I don't recall the pressure. 200 degrees, 200 atmospheres. I don't know, but the catalyst it had a catalyst. Phosphoric acid, need yeast as a catalyst? Yes. Does not need a catalyst, ethene to ethanol. Steam. No, yeah, not phosphoric. Steam at 350 degrees. I guess I'm just going to hold this. I don't recall the catalyst for ethene. Very fast reaction, very slow reaction. I'm just happy with that. Low yield of, this is actually the reverse, right? And I guess B is the answer, right? B seems, but why can't I recall the catalyst for ethene? What's the catalyst for this reaction? Ethene reacting with steam? Wasn't it phosphoric acid? H3PO4? I think that's the catalyst. Yes, it is, right? Why? Oh, I was meant to say this is the reaction. I'm a bit distracted. Right? Very slow reaction, very fast reaction. How do I know about the yield? I know about the yield because I've seen a lot of house, if you guys know what that is. I think higher than 15% of alcohol, ethanol, this is the same alcohol that goes into drinking alcohol, right? So more than 15% makes this a substance poisonous. So what? Yeah, you don't have a high yield of ethanol. You have a low yield of ethanol. And high yield obviously over here because it's not a reversible reaction or anything. Okay. 60 atmospheres? Yeah, that makes sense. So it's at 350 degrees, 60 atmospheres with a catalyst, which is phosphoric acid. Okay. This is one question where I've seen, especially in IGCSE, there was a 3-mark question asking for the catalyst condition and pressure for making for hydration of an alkene. So yeah, if you forget any reaction, don't forget this one. And I say that right, I forgot the thing. ठीक है. When will Sir Bilal take class? Sir Bilal will take, I think not anytime soon. Like I think a few weeks I'll be taking classes. Then he'll come in. He's a little busy with taking classes for his A-level kids. So I'm taking it. Litmus. Litmus won't really work for SO2. Let me check if you can use it. I don't think it'll work because SO2 needs to first turn into SO3. This is my understanding. SO2 is not soluble in water, I believe, or not turns into an acid directly, or not a strong acid. Let me check. I think I'm wrong when I say that. SO2 test with litmus. Because first it needs to turn into SO3, and that SO3 causes acid rain, right? That's my understanding. It does do it. Sulfur dioxide will turn moist litmus paper from blue to red. Yeah. I guess you can do it. Why don't you do it? So I'm trying to figure out why don't you do it. Yeah, okay. I have a strong feeling it's because sulfur dioxide is toxic, very toxic. So you want to have a litmus paper near it. You have to have the gas escape in the air and catch it with the litmus, right? So you don't do that because if in case anyone inhales it, they might get sick very easily. It's not just bad for you, it's really toxic. Like carbon monoxide, you can kind of, smell it for an hour or two, then die. Sulfur dioxide would be a little more dangerous. So I think they pass it through water where it dissolves and oxidizes with. So litmus paper, even though you'd will be able to tell if it's sulfur dioxide, I think that's the last thing you'll be doing. I guess that's why they don't do it. Right? Does that make sense, Hasnan? I think that's why they recommend oxidizing agents instead, if you want to test for it. Okay, I think we're done with this. No, there's one more question, but actually not really, because it's the same question being repeated. Okay, moving on to our last paper for the day. Last paper. That's a repeated question. See again, they didn't even bother changing the options. Right? Moving on. Some properties of substance X are listed. Okay, that's repeated. Okay, new question. Which is cryolite? Why is cryolite used in the extraction of aluminum by electrolysis? And I was very, I think even last time I was confused with this question, and I was upset when we did it a few weeks ago. The reason for it is most books say it helps the melting point of aluminum oxide, right? Of bauxite, so you can, or aluminum oxide, so you can electrolyze it. But over here, they've just changed that to aluminum, but no books really talks about how it does it. And apparently it does it by dissolving it. So it's one of those questions where like, चमाट मारने का अगर आपको दिल चाहता तो please जाके मारें. The answer is C. And they're trying to trick you. They want you to read this as aluminum oxide instead of aluminum. Right? That's the thing. Are you guys upset? Messam isn't upset. Messam is in grade 8. That's why Messam. You have 2 years to take your exams. That's why you're not upset. If you had your exams in like a few weeks, you'd be like, oh, what's wrong with them? Why are they doing this to us? Yeah, okay. I think after this, it's our last question. Okay. That was our last question. Yeah. We're done with 3 papers. All right. Shall we end it right now, or do you guys want to do maybe another paper? What do you guys think? Should I check? I won't be prepared for papers, I guess, not that I was prepared this time around. Let's see if I have any other papers. What do you guys think? You guys want to end it? Or that's not ready. 1, 3, no, that is kind of ready. Okay, we can probably do this. So your call. If you want to do it, we can. My choice? What do you guys say? Another paper? We can do June paper 2-3. Because I think we did paper 2-2. Did we? Yeah, I think we did. But we never did paper 2-3. Yeah? Okay, let's do it. And we can brag about how we've done all 2019 papers. I have a feeling we might have just done this as well, but doesn't look like we have. Give me 1 second. Give me 1 second. And it is here. All right, let's try this question. Who do you not like me taking classes? I guess. Hydrogen chloride is released at P in the paradox shown. Universal indicator paper turns red after 38 seconds. Okay. The experiment is repeated using sulfur dioxide. Oh, look. What is the result of sulfur dioxide? it is red, right? We know that. Oh, it's not litmus paper, it's universal indicator paper, which will do the same thing. At least these are acidic colors. But will it be heavier, or will it not heavier, but will it be faster or slower than hydrochloric acid? I'm gonna say it's gonna take more time, because sulfur dioxide has an MR of 64, about twice as heavy almost as this guy, slightly less than twice as heavy. So it's gonna be 51, and the answer should be, for all intents and purposes, be D. Yeah, does that make sense? And I am confident it's red because both hydrochloric acid and sulfur dioxide are acidic gases. ठीक है. RF values are used to identify unknown substances using paper chromatography. Which statements about RF values are correct? RF values are always less than 1. Yup. RF values, distance traveled by the solvent, distance traveled by the unknown substance. It's actually the other way around. The higher the RF value, the further the unknown substance travels. Isn't that true? The RF values are not affected by the solubility of the unknown substances. I think they're affected exactly by that, because it's the solubility that carries them, right? So 1 and 3, the answer is B. They travel because of their solubilities. Yeah? Why is this difficult? I'm thinking sodium is 23, the MR. Isn't that right? 23 plus 7 is 30, then 40. 25 over 40 is, let's try doing this without a calculator. 5 times 5, 5 times 8, what's 5 over 8? I don't know. But I just now have to multiply this by 2. Why? Because it's in 500 centimeter of water. If I multiply it by 2, I can just find out the concentration. If I don't want to multiply it by 2, I can divide it first by 500, then multiply it by 1000, which is, in other words, multiplying it by 2. So that's 10 over 8, and that's going to be 1.25. Because 2 times 4 and 2 times 5. The answer is C. Yay! I miss doing maths like this. Yes? What do you guys think? Was this easy? Why not? I don't know why this was considered a difficult question. Yep, okay. With statement about properties of elements of group 1 and group 5, 6, 7 are correct. Bromine displaces iodine from aqueous solution of potassium iodide. Okay, chlorine, bromine, and iodine are diatomic gases at room temperature. Chlorine, bromine, and iodine are diatomic gases at room temperature. Actually, they're the whole spectrum of your states of matter. Chlorine being a gas, bromine is a liquid at room temperature, and iodine is a solid at room temperature. So this is incorrect. Lithium, sodium, and potassium are soft nonmetals. Are soft metals. Lithium, sodium, potassium have increasing number of electrons in their outer shell. Not their outer shell, their total number of electrons. ठीक है. And bromine does displace iodine because bromine is more reactive and successfully displaces iodine to form iodine. Do you guys know the equation for this? Let's make it group. This reaction takes place. Yeah. Yep, yep. Shall we? Yep, yep. Okay. Catalytic converters in car exhaust. Finally a pollution question. Change polluting gases into non-polluting gases. Which statement about oxides of nitrogen in car engines are correct? The nitrogen in oxides of nitrogen come from compounds in petrol. Do they? I mean, do they? The oxygen in oxides of nitrogen come from the air in the car engine, right? Yeah. Both nitrogen and oxygen comes from the, yeah. Catalytic converters convert oxides of nitrogen into nitrogen and other gases. This is kind of difficult for me. And other gases. What actually happens is it takes NO and CO and turns it into N2 and CO2. It's not balanced, but this is what happens. Is that how you balance it out? No, it's still not balanced. How do you balance it out? How do you balance it out? Okay, never mind. I don't want to balance it out. I should though. But does this statement complement the equation below? Catalytic converters convert oxides of nitrogen into nitrogen and other gases. I guess they're trying to highlight that it's NO turning into N2 and O2. So I'm going to say this is wrong, right? So I'm going to say 2 only is correct. Yeah, fairly confident. Into nitrogen and other gases. Convert oxides of nitrogen into nitrogen and other gases. Yeah. What do you guys think? Yay or nay? I'm confused with the phrasing over here. Yes? Yeah, I don't know. I'm confident it's C, but I'm not sure if it's C. Let's come back to this. I'll try doing this in the next class, or confirm it in the next class. Meanwhile, ammonia. What is the effect of lowering the temperature on the rate of reaction? This is exothermic. Forward is exothermic. What is the effect of lowering the temperature on the rate of formation and equilibrium? Equilibrium yield decreases definitely, right? But the rate increases. The answer now is C. I think we understand this better than others. Lowering temperature. Yeah. Lowering temperatures I was going with. Lowering temperatures. Why am I confused? The ammonia is manufactured in an exothermic reaction, right? Equilibrium yield will, let's go forward, exothermic, right? Lowering the temperature, oh yeah, increasing, yeah, okay, that's why I'm confused. Increasing the temperature, if you increase it, will favor the endothermic side. But if you decrease it, it'll favor the exothermic side. So if the forward reaction is happening, and yeah, so much for we know it better than others. But the rate, what's going to happen to the rate if the temperature, oh well, that's going to decrease obviously. No question there. And the answer is not C but B. Yeah. Make sense? Make sense? Increase and increase. Lowering the temperature will decrease the rate for sure. No questions there. Equilibrium. Lowering the temperature will always favor the exothermic side, the easier way to think about it. Alright, does that make sense, Amna? Okay, let's move on. Which row shows the conditions for the contact process? Hey, look at that. I think we've done this question. This is where we realized the pressure was 2 atmospheres. It's 450 because vanadium O5, vanadium 5 oxide, not vanadium O5, does not work for lower temperatures, so they keep it high. Pressure is 2, and of course it's vanadium 5 oxide. So it's C. It's all C. Always has been. Yeah, Quran is right. ठीक है. 34. The diagram represents a lime kiln used to heat limestone to a very high temperature. We've done this question before. What leaves the kiln at X? You guys tell me. What will leave? Some sort of calcium. You throw limestone in there, what's going to leave? What happens to limestone when you heat it? It becomes hot. So the reason they throw limestone in there is for the slag, and it also produces carbon dioxide, which reacts with carbon to form carbon monoxide. Remember? And the carbon monoxide is the true oxidizing agent for iron, right? Oh, reducing agent. Iron is reduced, yeah. True reducing agent. Because carbon monoxide gets oxidized, right? Turns to... Right? And of course the slag will come out, but the slag is not highlighted. So the other thing that will come out is calcium oxide. See, I don't like this question. Not a fan. Yeah, decomposition of calcium carbonate. Essentially that. Maybe it's easier than I think. I'm just biased. A section of polymer is shown. How many different types of... Oh, finally. We find our ester links and we cut them there. Polyester. Are all these yellows same? Are all these blues same? Yep. Yeah. All right, easy. Okay, guys. We're done for today. We did 4 papers. 2019, all the difficult questions highlighted by Cambridge for these 4 papers. Not bad. We're done with every 2019 paper for IGCSE. And I don't think we found any question that was different for O-levels. So it's just good practice for anyone taking O-levels to go over these questions. Most weren't difficult. I think people just get overconfident and get it wrong. But oh well. I'll see you guys when? We won't have a class tomorrow. I'll see you guys Tuesday. Right? Tuesday. All right, guys. Bye-bye. Take care. Bye-bye, guys.